Hello, this is our Capstone project. We've decided to do an FA-18 flight simulator. So first we have an introduction, when like how we came to the conclusion of what to build and what we decided to do, the engineering design process, then our milestones, then the challenges that we faced leading to the results and reflection. So the introduction.
So, as we were posed the question, what exactly we wanted to do for our final project, we wanted to build a flight simulator in order to get the younger group of people to influence them and push them into the field of aviation. Because both of us, we love aviation, and right now there's a great deficit of airline pilots and military pilots.
So that's why we chose this capstone project. But it also led to why we worked as a group, because it was a very big project to take on, because it included a lot of coding, a lot of 3D printing, a lot of different wiring aspects. So having two people to work on it was a lot better than one, and it actually probably was the difference between making this project possible and not being possible for the class.
So on to our engineering design process. So we first identified the issue, which of course was to create an idea of the project at capstone level, and we did our flight simulator. For our research, we researched other previous homemade projects, such as the Warthog project, which is a simulator created by a veteran based off the A-10, and it uses a 1-to-1 scale replica of the A-10 Warthog AC-10-2. And we also found some commercial cockpits that span from $7,000 up to the $15,000 range.
The main issue with these is that it's cost range. The things that they were able to use to make it come from a website that makes fully printed out and perfected designs of each part of the cockpit. However, each one of those separate parts, and it would just be a panel about like this big, is about $500. So we wanted to be able to make it more cost effective.
So as we wanted to make our sim, we came across two different ideas. The first one was to make an F-16C Block 50 cockpit, and the other one was to make a F-A-18C early cockpit. We chose the F-18 because the throttle component of the F-16 is extremely complicated to build here in the engineering lab, and if we were to buy just the throttle from, let's say, a company, the throttle would cost around $700 to make. So then we chose the F-18 because we already have a throttle component that's very similar to the actual aircraft. So for our planned development, we figured out the best specs for our computers and the components, such as the types of switches we wanted to use, two-way, three-way, and the specs of our computer to make sure that DCS can run smoothly and so that it can handle all the USB ports that we need. For creating the project, we used 3D prints as it was more cost effective, and we put switches on the hull. 3D printing was the most effective way to get this done, as we could create our own design and then just 3D print it instead of getting it sending the files and getting it manufactured somewhere else. And then we also were testing the project as we coded the switches. We wanted to make sure that the switches that we had worked and that the software that we had worked as well with the switches.
Milestones. So our first milestone, which was due September 13th, we just wanted to get the bill of materials in to make sure that we were able to get all the components that we needed at a cheap price, because as we mentioned earlier, a lot of the things needed to build a flight simulator was very expensive. So we want to make sure that we could make it within our range of price. And then our second milestone was to just organize all the things that we got, because we received a lot of switches, a lot of wires, as well as a lot of different monitors and multiple 3D prints that were coming in. So we just wanted to be able to organize that and then model it in order for us to have the most efficient time working on the project, and also for it to get done in the best way possible. So then for our third milestone, we continued to model the actual design of it through 3D printing, and then we decided to work on our own computer, as there wasn't one in the engineering lab that would be able to run the DCS, which is what we were planning on using the flight simulator through, without having its own specifications that we needed. So we decided to go to Micro Center and we made our own computer.
And during the design process, we actually had a hardware limitation where the laptops, the 8 gigabytes of RAM was not sufficient for the modeling that we were doing. So then we had to do the majority of the modeling at home on our desktop computers, which had 32 to 64 gigabytes of RAM.
And once we finished that, we led to milestone 4, which is when we started fully assembling the actual pieces of the 3D parts. Then onto milestone 5, once we had gotten the base outline and skeleton of the actual 3D object for the flight simulator, we decided that we needed to put all of our switches in and began just placing all of those, knowing where they would go, and wiring it so that they would be easily accessed later so we could code it. Which then, on our 6th milestone, we decided to code it a bit, and we just figured out how we were going to use it through a process called DCS BIOS, which is how you connect certain switches to DCS. So then onto our 7th milestone, we finally decided that we needed to set up the projectors for the displays so that we would have a wider display for our project in order for it to have the best field of view and for us to be able to see the entirety of what we're working on without having the full cockpit in view because it takes away from the realism aspect. And then onto our 8th milestone, we added all of the key components such as the throttle or the pedals and the stick, just so that we have the final parts that were pre-made and pre-purchased, so we got all of those made and set. And then on our 9th and 10th, we wanted to just test the product, make sure it worked and that everything was accessible, and then finally just to make it look as nice as we could. So, challenges that we faced. There was a lot. The first of which was mainly around what I was doing, which was the coding. DCS BIOS is a system that has been made for many years now, except the actual startup process and way to get it running has not been updated recently, and the most recent time that it has been updated, it was updated for Linux. So I had to do a lot of figuring out ways to switch all these Linux programs into being window processes so that we could finally get it to work. And eventually, after a very, very long time, taking almost into milestone 8 time, we finally got it to where it was able to be coded perfectly well.
As well, we also had issues with 3D prints. Since we were using ABS, PLA, and PETG, the ABS is notorious for warping. So I just ran into issues of a lot of warping since the garage that I had my printers in, at the time we were printing it, it was around 13 degrees Celsius, which the air then leaked into the printer and then caused the corners of the ABS prints to warp. Printing orientation is also another big factor that I found out is really important. If, for example, we print something vertically, and it will have weaknesses in the layer lines. So then I would have to reorient the object to print it horizontally so that it wouldn't break as easily.
And probably the biggest challenge we faced is just working together and team communication. Because the way that we went throughout the project, we each had specific parts that we were best at, while I did most of the coding on the computer and a lot of the digital aspects. Alejandro did a lot of the 3D printing parts, which worked the most efficient way because we got the most work done in the least amount of time. But we did not expect for both of us to be sick a lot of classes, which led for when I was done with the majority of my coding, I had little knowledge of what I needed to do for the 3D prints, and likewise for when I was gone and Alejandro needed to help with the coding. But we eventually got it done, and it ended up with the results that you will see very shortly. But for now, we have pictures of just how we went through the process. So these are 2 pictures of the 3D prints. These are both separate skeleton versions of where we would put each switch on the actual console. As well, this is a picture of the first half of the code that I had to do, which was actually getting it set up to Linux. And then that is the computer that we built. And then the overall result, which will be seen. Overall, reflections for myself, I wish that I knew more about every aspect that we were doing, and that I spent more time to communicate with what my partner was doing, so that I knew exactly how to manage those things when I needed to work by myself.
And I wish that I knew more coding, and so I could help out Gabe with everything else. But I learned a lot from modifying files, game files, to doing Lua scripts, to learning a lot more about 3D printing that I thought I already knew about.
And I learned a lot of C++. Thank you so much.
Yes, I'm turning it.
He's trying to like mount it.
Oh, nice.
Reindeer.
Alright, now the best way to end this is to crash it.
To crash it.